ग्रोसरीज पे 30% तक की सेविंग्स। Amazon, ग्रोसरीज की अपनी दुकान।
Since the start of the space age, more than 8,800 objects have been launched into Earth's orbit. But in a few years, that number could increase significantly.
యాక్చువల్‌గా ఇప్పుడు మనకి ఇంటర్నెట్ ఉంటుంది. ఇంటర్నెట్ ఎలా వస్తుంది మనకి ఇంటికి? వైఫై మొబైల్‌లో ఇంటర్నెట్ ఉంటుంది. లేకపోతే ఇంటర్నెట్ కనెక్షన్ తీసుకొని వైర్ వల్ల వస్తది. అట్లా కాకుండా శాటిలైట్ ఇంటర్నెట్ ఒక కాన్సెప్ట్ ఉంది. శాటిలైట్ ఇంటర్నెట్ అనే కాన్సెప్ట్ అంతగా చాలామందికి తెలీదు. ఎందుకంటే ఇంటర్నెట్ చాలా స్లోగా ఉంటుంది. ఆర్ కాస్ట్లీ కూడా ఉంటది. ఎందుకంటే అది ఏదైతే శాటిలైట్ మనకు మొబైల్ టవర్ నుండి దూరం ఉంటే మనకు వీక్ సిగ్నల్ వస్తుందో, అలాగే శాటిలైట్ కూడా ఇప్పుడు ఎగ్జిస్టింగ్ శాటిలైట్ ఇంటర్నెట్ ఇచ్చే శాటిలైట్ చాలా దూరంలో ఉన్నది. కాబట్టి డిస్టెన్స్ ఎక్కువ చేయడం వల్ల అది స్లోగా ఇస్తుంది. ఆర్ ఇంకా డేటా ఎక్కువగా రాదు. ఆ ప్రాబ్లం ఉంది. అదే ఇప్పుడు కొంచెం అర్త్‌కి దగ్గరలో శాటిలైట్ పెడితే గన అప్పుడు చాలా ఎక్కువ పెట్టాల్సి వస్తుంది. అప్పుడు ట్రాన్స్మిషన్ టైం కూడా తగ్గుతుంది. ఆర్ ఎక్కువ డేటా కూడా పంపించవచ్చు. సో ఇది ఎక్కువగా మెయిన్‌గా రూరల్ ఏరియాస్, డెవలప్డ్ కంట్రీస్, విలేజెస్, మౌంటైన్స్ ఇలాంటి తక్కువ పీపుల్ ఉండే ప్లేసుల్లో వాడడానికి పనికొస్తుంది. అక్కడ మొబైల్ టవర్స్ పెట్టడం కానీ, వైర్ పెట్టడం కానీ అంత ఫీజిబుల్ అవ్వదు టెక్నికల్‌గా. అందుకోసం ఇట్లా చేస్తున్నారు. స్పేస్ ఎక్స్ వాళ్ళు కూడా కొన్ని శాటిలైట్స్ పంపాలనుకుంటున్నారు. దాదాపు 42,000 శాటిలైట్స్ పంపించాలనుకుంటున్నారు. ఇంకా వేరే కంపెనీస్ కూడా ఉన్నాయి. జెఫ్ బెజోస్ కూడా ట్రై చేస్తున్నారు. ఇంకా ఎయిర్టెల్ వాళ్ళు కూడా ఏదో కంపెనీ మీద ఇన్వెస్ట్ చేశారు. వాళ్ళు కూడా పంపాలనుకుంటున్నారు. దీనివల్ల ఏమవుతుంది అంటే డెమోక్రటైజ్ అవుతుంది. ఇంటర్నెట్ డెమోక్రటైజ్. ఇప్పుడు విలేజెస్‌లో మేబీ ఆఫ్రికాలో విలేజ్ ఉంది. అక్కడ ఇంటర్నెట్ రావాలి అంటే నువ్వు ₹1,00,00,000 పెట్టాలి. 10,00,00,000 పెట్టాలి. మొబైల్ టవర్ పెట్టి ఇంటర్నెట్ కనెక్షన్ ఇవ్వాలి అంటే ఇది అయ్యే పని కాదు. అదే డిఫాల్ట్ కొంచెం అఫోర్డబిలిటీలో కొంచెం కష్టంగా అయినా 5,000 అయినా, 3,000 అయినా, 10,000 అయినా ఇంటర్నెట్ విలేజ్‌లో పెట్టొచ్చు, ఆఫ్రికాలో పెట్టొచ్చు అంటే ఎవరైనా స్టార్టప్ ఎవరైనా డెవలప్ కంట్రీస్ వాళ్ళు ఇండియాలో వాళ్ళు కానీ, అమెరికాలో కానీ అక్కడ పెట్టి మా కంపెనీ పెట్టచ్చు. మేబీ శాటిలైట్ ఇంకా సోలార్ ప్యానెల్ పెట్టి కరెంటు పెట్టి అక్కడ ఉండే వాళ్ళనే జాబ్ ఇవ్వచ్చు, ట్రైన్ చేయొచ్చు, ఇవన్నీ చేయొచ్చు. ఫస్ట్ ఇంటర్నెట్ కరెంటు మెయిన్ కదా, అట్లా అనమాట. సో దట్స్ అబౌట్ ఇట్ గైస్. సో ఇట్ ఇస్ ఇంట్రెస్టింగ్. ఇదే ఎగ్జాంపుల్ చెప్తున్నాడు చూడండి.
Internet offerings over
కరెంట్
satellite,
కంపెనీస్ ఉన్నాయి.
they
వీసా
tend
సెట్
to be
అనేది
more
ఒక కంపెనీ
expensive,
ఉన్నాయి.
and they also tend to have fairly low numbers of users. In the United States, there are only about 2 million customers out of our more than 100 million households that utilize satellite internet.
One big
దాదాపు
issue with
2
current satellite
మిలియన్స్
networks
ఏమో
has been
అనుకుంటున్నాను
latency.
అంటున్నారు.
Traditional satellites orbit very far away from the Earth, and that
చూడండి
distance
చాలా దూరంలో
increases the
ఉన్నాయి
overall
శాటిలైట్
latency in the
చెప్పండి.
network. Latency is the responsiveness
లేటెన్సీ
of the
అంటే
network.
ఇప్పుడు
So if you're streaming something
శాటిలైట్
online,
నుండి
it's how quickly
మనకు
something loads or
మన
how
మొబైల్
smoothly
కానీ
it runs.
ల్యాప్టాప్
Most internet satellites today operate in what's called geostationary orbit, which is around 36,000 kilometers above Earth's surface, and remain fixed on top of one area. But the satellite systems that SpaceX, OneWeb, Amazon, and Telesat are proposing will operate in what is called low Earth orbit, or between 180 and 2,000 kilometers above Earth's surface. In theory, this should cut down on the latency issues, with speeds up to 20 times faster than current geosatellites. But to get the same coverage with LEO satellites, you need more of them.
The speed of transmission of light in fiber is 40% slower than it is in air or vacuum. So, in fact, you can build a quite extensive low Earth orbit satellite network and have very fast communications capability.
Because they're lower, you actually need more of them to cover an effective area, right? They just can't see all the parts of the Earth. So our higher orbiting satellites used to be able to get away with a much smaller number of actual orbiting vehicles, whereas these new low Earth orbit constellations do require more. However, there's more to it than that. They also need to have adequate power, and if they're going to provide lots of people with connectivity, they need to have lots of capacity. Hence, you need more satellites to do that. Whether having 10, 20,000 or more satellites orbiting is warranted for any of these is still yet to be seen.
Satellites still need something back on Earth to receive their signals.
Beyond building the satellites for these mega constellations, these companies will also have to invest in heavy amounts of infrastructure on the ground. That will look like thousands or even millions of antennae all around the world to receive the signal from the satellites and distribute it to consumers on the ground. Plans to offer internet from space may sound familiar, as both Facebook and Google have considered developing these kinds of satellites before. But Facebook hasn't announced anything in over a year since talking about its Athena satellite. And Google is one of the main investors in SpaceX's system, so they're expected to look very closely at how Starlink is developed. The top companies pursuing mega constellations are tech giants SpaceX and Amazon, as well as satellite builders OneWeb and Telesat. The leader in this category, at least by quantity of satellites launched, is SpaceX, as they've launched 120 of their Starlink satellites so far this year and are set to launch another 60 very soon.
And we have confirmation of deploy. You can hear the team in the background. This is an incredible moment for SpaceX. You can see those flat-packed Starlink satellites slowly gliding away from the top of the second stage. This is the highest number of satellites that SpaceX has ever deployed in a single time.
SpaceX's utilization of its renewable Falcon 9 rocket dramatically decreases the cost of sending satellites into space. FCC documents show that SpaceX expects Starlink to become operational once at least 800 satellites are deployed.
The main value of Starlink is providing low latency, high bandwidth access to sparse and moderately sparse, relatively low density areas. It's probably able to serve like 3 to 5% of people in the world.
SpaceX began with the idea to launch 12,000 satellites, but in October 2019, the company requested permission for an additional 30,000. SpaceX has also put in a request with the FCC for up to 1 million Earth stations, which end-user customers will utilize to communicate with its satellites. The U.S. Air Force is also testing Starlink satellites on its military planes, and has so far reported favorable results. SpaceX has said that it will begin offering internet service by 2020.
Hot on SpaceX's heels is OneWeb, which is already building its own satellites, having launched 6 earlier this year.
We've done a joint venture with Airbus, and we have a factory at Cape Canaveral, and we've really set up a supply chain, and we're using the same satellite over and over again to populate our system. And we're going to produce 650 for the first layer of capacity, which will be for global coverage, but we'll go all the way up to 2,000.
Like SpaceX, OneWeb has its own set of big-name backers, including SoftBank and British business magnate Richard Branson. OneWeb says each of its satellites cost about $1 million to produce. But unlike SpaceX, OneWeb must depend on Russian-built Soyuz rockets to launch its satellites.
Unlike OneWeb and SpaceX, Amazon has yet to launch any satellites and is early in developing, as it's still seeking regulatory approval for its Project Kuiper network.
Amazon's Project Kuiper plans to launch a total of 3,236 satellites into low Earth orbit. Back in April 2019, Amazon hired the former leader of SpaceX's satellite program to run Project Kuiper after Musk fired him. According to reports, Musk had become frustrated with the pace of Starlink's development. Though it's behind on building satellites, Amazon already has a head start on ground infrastructure. In November 2019, the company announced AWS Ground Station, a new business unit that will build 12 satellite facilities around the world to provide the vital link needed to transmit data to and from satellites in orbit. Plus, although technically a different company, Jeff Bezos' Blue Origin would be the obvious choice to launch these satellites.
Also in the mix is Canadian satellite builder Telesat, which has received significant investment thus far, but hasn't launched any satellites yet. They're negotiating with companies that would build their network, which is estimated to cost about $3 billion.
Astronomers are now very concerned about this new large constellations that are being launched. The number that are planned would exceed all satellites launched to date. And the real challenge here is not necessarily the number of new launches, it's the brightness, how bright these things will be. That they will saturate our detectors and cause all sorts of difficulties in astronomical observing.
This image, taken from a telescope in Chile in November 2019, illustrates the concerns from astronomers. The telescope, meant to see images of distant stars and galaxies, instead captured the light trails of 19 Starlink satellites. Some astronomers took to Twitter to express their concerns after SpaceX launched the first 60 Starlink satellites back in May 2019.